y'all. Today we're going to look at inverses. What is an inverse? The basic thing to remember is in an inverse, x and y switch places. So if I had a point 3, 1, the inverse would be 1, 3. You just switch x and y. You don't change their sign. You just switch where they're standing. Let's practice a little bit. This will be a review from Algebra 2, but it's an important review for this unit. I'll let you read through this list, and we'll kind of talk about it when we're done. These notes are on Canvas. If you choose to print them, you may. You also may just write on paper. You do not have to print these. So find the inverse. All we do to find the inverse is switch x and y. Well, this doesn't have a y, you say, but we can write that as y. So y equals 2x plus 5. So now I'm going to switch x and y. X equals 2y plus 5. And then we are going to isolate y. So I will bring that 5 over, x minus 5 equals 2y, and then we're going to divide through, so y equals x minus 5 over 2. Now we need to let somebody know that this is the inverse, so there's a symbol for that. So that would be y negative 1 equals x minus 5 over 2. This is the symbol for inverse, and since they started with an f of x though, I'm going to say f of x equals x minus 5 over 2. See, that's just not too bad, right? Now here's the magic. Find f of 1. So if we took 1 and plugged it in here, 2 times 1 is 2 plus 5 is 7. That means if I take 7 and I plug it into the inverse, since f of 1 equals 7, that means there's a 0.17 on the graph. So on the inverse, if I plug 7 into the inverse, this means plug 7 in for x. This means to the inverse. So plug 7 in here. 7 minus 5 is 2. 2 divided by 2 is 1. So that means there's a 0.71 on the inverse. That's a test that you can do to see if that actually works. 1, 7 goes to 7, 1. That would be proof that it was an inverse, right? So let's try this one. So again, we're going to switch x and y, so we better get a y. All right, what are we going to do next? Isolate the y. So, well, let's switch them. So x equals y minus 2 over 3. Now we will get that y all by itself. So we're going to multiply both sides by 3. And we'll have 3x equals y minus 2. Then we'll add 2 to both sides. So y equals 3x plus 2. So we need to let people know that that's not just y, it's the inverse. So we'll put a negative. And really, they started with f, so we should end with f. Let's do our simple test. We'll plug 5 into the original. 5 minus 2 is 3, and 3 divided by 3 is 1. So f of 5 is 1. That means the 0.51. Therefore, on this one, 1, 5 should also be a point. So we're going to take 1 and plug it into the inverse. 3 times 1 plus 2 equals 5. So that means there's a 0.15. Again, it worked because if 5, 1 is a point on the function, 1, 5 is a point on the inverse. Now, if you're told to prove that 3x minus 5 and g of x equals x plus 5 over 3 are inverses, in other words, this one is saying, is f of g of x equal to g of f of x? Another way to prove that they're inverses is to plug them into each other. If I plug them into each other, I should get x both times. So let's take f of g of x. So I'm going to write down f, right? But I'm going to leave a blank spot where there was supposed to be an x, and I'm going to put g in there. I'm going to use g as pink. The other thing I'm going to do is this one. So I'm going to leave G open. So x plus 5 over 3. And this time, I'm going to plug F in there. This is G. The pink part's G. I'm going to put F in there, and F is 3x minus 5. Now, on both of these, we should be left with nothing more than the letter x. So here we know that the two 3's will cancel, and I have x plus 5 minus 5, and 5 minus 5, that's just x. Over here, if we look at that, we have 3x minus 5 plus 5. So those will zero out, and I have 3x over 3, which just leaves x. Okay, so whenever you plug one equation into another, if all you're left with is an x, either way that you go, then you know those are inverses of each other. Okay, so let's kind of look now and see. An inverse of a function will undo what the original function does to the number. In other words, if I plug 1 in and get 7 out, the inverse will take that 7 and turn it back into a 1. That's what this first bullet point means. If f and g are inverses, then f of g of x equals g of f of x equals x. That means when you plug them into each other, either way you plug them in, you're going to get x as an answer. The next one we're going to talk about in a second, so just a minute. We looked at finding an inverse from an equation. That's an algebraic way. I also want you to be able to do that numerically. So use the table to find the following, the inverse of g of 2 and all of these things. It gets pretty scary when you see tables like that, so it's much easier if you break the table up. Remember what we said. If you are working with an inverse, x and y switch places. So I'm going to do my f as kind of pink. So if negative 2, 5, if these are the x's and these are the y's, when I take the inverse, they're going to switch. So these are going to be my x's. And now that x is going to become y. And these are the y values. They are now going to become the x's. I think it's a lot easier if you just separate your tables. You can read them together by looking at this whole table, but it's really easy to get mixed up. So I highly recommend writing 2 of these. Okay, so let's look at the green one. So if these were my x's, when I take the inverse, those are now going to be my y's. Right? And if these were the y's, because remember, this is x, this is y. These were the y's, so they're now the x's. Pause this if you want to for a minute and look at how we just switch the numbers. Once you switch the numbers, this is very easy to read. So it says the inverse. Now remember, when you see something in parentheses, that's always an x. So this says if x is 2, what is y? And they want you to look at the inverse. So on the inverse 2, what is the answer? 0, right there. So this one says, right, first we do, this is the inside function, so we do it first. So f inverse of 1. So it says look on the inverse where x is 1. Well, where x is 1, your answer is 2. Right? Now it wants you to plug that into the outside one. So now we're going to say g of this answer. So g would just be this one up here. So if x is 2, g is 7. And if you need to pause this to think about it for a second, go ahead and do that. This was a composite function because it's got the open circle. This one is simply subtracting. So we're going to find f of 2, right, minus g inverse of 2. So f of 2, we're going to go look at 2. F is 1. Now we're going to look at the inverse. So that's this one, where x is 2, g is 0, and 1 minus 0 is simply 1. Okay, right here it says find G inverse of 7. So we're going to use this one. Now when X is 7, G is 2 from our chart. And now it wants you to find F inverse of that 2. So you have to decide, we want F. Do we look at this one or this one? It's saying inverse, so we look at this one. And if X is 2, Y is -1. So there's no work to really do on that. It's just a matter of being able to read that chart. Okay, so we looked at over here, this was an algebraic representation. This is a numeric representation. What about a graphic representation? That also brings us back. Now we looked at this. Let's go back here for a second. So we looked and it undoes something. If you plug a 3 in and get a 1 out on the inverse, you plug the 1 in, you get a 3 out, right? That's what that means. Right here, the inverses, we plug them into each other and get X. That's what this is talking about. We looked at algebraic and we looked at numeric. Now I want to look with you, the inverse of a function is the reflection over the y equals x line. So let's look at that. So what does a cube function look like? Okay, that's one of our parent functions. There's the cube. And what does a cube root look like? Well, from your parent functions, cube root looks like this. Are they inverses? Well, to know if they're inverses, you're going to ask yourself, does this 45-degree line act like a mirror? Does it act like a mirror? It does act like a mirror. If you were looking at this, it cuts it exactly in half. Okay, so that's the graphic representation. What about the quadratic and the square root? Well, quadratic looks like this. Square root looks like this. Now, I want you to notice something kind of cool. If we only used this one and this one, it would be, but a square root, a quadratic has both sides. So if we were to flip it, we would have to have that, but then this would fail the vertical line test and it would not be a function. So that's no good. So many times if you want a quadratic and a square root to be inverse functions of each other, the only way that can happen is if on the quadratic they specify x is greater than or equal to 0. So then you would just be using this piece and then it would work. But the whole thing as a whole does not work, does it? Okay, so did that clear up? What did that clear up? Graph and the inverse function. Graphically switch x and y and graph it. Okay, one other little thing I want to talk about, and then this is where we're going to do the graphic one. It's kind of hard for you to graph this log because logs have a lot of decimals and weird answers, but it's very easy to graph this. So let's just say, what's 2 to the 0? Well, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8. Now what about 2 to the -1? 2 to the -1 actually means 1 over 2, so that's 1/2. And 2 to the -2 means 1 over 2 squared, which equals 1/4. Those are very easy to do. And now what we can do, that gives me the exponential. If I need the log, I simply switch the numbers. So the x's become the y's, and now these go here. So you can see the advantage of doing an exponential. Since you don't know how to do that one and they're weird answers, we're like, hey, wait, I don't know. but we can do the exponential and see that. So let's graph this very quickly, and I think then I'll let you go for the day, right? So let's graph the green one. So -2, 1/4, -1, 1/2, 0. Now, if you remember from our work yesterday, this was the point you were supposed to memorize. That's called a pivot point. I like to refer to it as the pivot point, because if you have to move one around, you'll put that point on and then just draw your graph in. Okay, and it's kind of where the graph changes color, or changes direction, sorry, color. So 1, 2, 2, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So you can see what that looks like. Now let's graph the log. So 1/4, -2, 1/2, -1, 1, 0, 2, 1, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, and voila. So this would be on your list of things to do graphically. Switch the X and Y and graph the new points. That's what we're doing here. Now, does this line cut them in half? Yes, it does. So you can see those are a mirror. Now remember, because these are logs, whoops, I don't want pink. Because they are logs and exponentials, the green curve would have an asymptote right here, and the pink, the log curve, would have an asymptote right there. Okay, so an inverse is a reflection in the line y equals x. That's that 45-degree line. Okay. All right, there you go. One other thing I wanted to mention, the word one-to-one. Okay, 1-to-1, if you remember, means, so if I had this curve, can I draw horizontal lines through? No, I hit it twice. So this is not 1-to-1. That means its inverse is not an inverse function. And you know that because if I took the inverse, it would look like this, and that's not a function. Okay, so if something is not 1-to-1, it does not have an inverse function. All right. All right. I will see you later. Have a great day.